Good evening, everybody, or good morning, wherever you are. And this is a very interesting conference, and thank you for inviting me. Is the sound okay? Can you hear me?
Yes, we
Sound
can hear you. Yes.
wonderful. Okay. So this is my topic, and this is my affiliation, as you heard. We have a clinical department, and we also do research in complementary medicine and in what we call natural medicine, and phytotherapy clear is part of it. So we cooperate with several companies who are involved in developing and selling phytodrugs. So this is my outline. This is a very large topic. We can only scratch it. We can only touch some of the aspects. So I hope that in the future that anti-infectious therapies will be more driven by plant-derived drugs. So, but we have to do a lot on the way. I'll try to show you. So here's our history. In 5 years, we'll have 100 years of this wonderful discovery that led to the Nobel Prize. So you can think, if you're interested in the history of science, you can think what might have happened if he had not done this, this discovery by accident, more or less, if people had turned attention to anti-infectious agents to the world of plants earlier than to fungi. So I think the world would be different now. But of course, this is a story of success. You cannot deny this. In spite of all the problems we have today, it is a story of success. And of course, mankind and a lot of researchers and a lot of the money that went into it, they stuck to fungi. This is really amazing. Look at this point here. The second point, we have very few synthetic developments, inventions of components that are used nowadays as drugs. It's only these two families, to my opinion. That's very little in contrast to the many families of fungi that have been used successfully as drugs. And look at the last point, at least in the Western world, where I'm familiar with, in practical medicine, there is no guideline that says use this plant for an infectious disease. Here in my country, with help of our Society of Phytotherapy, we have come to the point that they are recommended maybe as second line in some guidelines, but that's it. Now we're all doctors all over the world, and of course also basic researchers. We're all confronted with these problems. You read this every day, but a little has happened from the practical point of view, and the resources, the treasures, I might say, that are hidden in phytotherapy, they're not known to the decision makers in the Western world, so we get really little support. This is an old statistic, but believe it or not, I never found a paper that is similarly smart to this one with more recent data. So I'm sorry, this ends 8 years ago. So here in colors, you have the countries by their development in reducing or increasing their per capita use of antibiotics. That's important, per capita. So the blue ones, that's about 11 countries all over the world. They have reduced. Now it's a little bit more. And the reddish and brownish ones, they're increasing. And it's, of course, countries with lots of people like China and India that's still on the increase. And if you compare a lot of countries in the world with their per capita use of antibiotics, the spectrum is not so wide. It's Turkey and Tunisia. I don't know why that make that are far on the left end, and the others they aren't that far apart from each other. This is from 10 to 40 DDTs per 1,000 inhabitants per day. So the consumption per person has increased by 39% in these 15 years. And as the world population has also increased, the overall increase is about 60% of antibiotic use. And from the ecological point of view, it does not matter that much how many people use it. The overall amount of certain problematic antibiotics is most important. So here we can make it very short. I think you've seen or will see in the next days a lot of this basic chemistry. And in the last talk, you saw on an excellent level, some examples. We have about roughly these 5 groups of organic molecules that are easily differentiated as families, and that have our hope for the futures. And the order here is by the frequency of their appearance and in the nature. So the last 2 ones, isocyanates, are very good candidates, but they're only found in few plants. And adenosine is only found in onion plants, as far as we know at the moment, whereas polyphenols is a constituent of almost any plant. You find them everywhere, but there are so many. We know of approximately 80,000 at the moment. So there are so many that belong to this basic structure that it's hard to say whether the polyphenolic content of a plant is biologically active and in which way, and whether it may be resorbed, it may be has bioavailability, and all these many problems that we have to touch until we get to a clinical result. Saponins are not mentioned that often, but they're very important, very interesting molecules, especially when it comes to respiratory tract infections, as they do not only expose qualities of the type of that we heard in last talk, like antioxidative and maybe even killing bacteria, but they also dissolve. They may, by relieving tension, it's substances that are active on the surface of fluids, and thus they may relieve tension and dissolve mucus in respiratory tract infections. This is a paper that looked into possible action of biomolecules against COVID-19. That was published last year, and it's a very smart paper. This is on theoretical, on computer background, and here you see a lot of the candidates are polyphenols. So a lot of bioactivity is actually in the compartment of polyphenols. But this is a hope, but still there are so many. Etheric oils, for example, they're more easily to overlook, I would say. And so it's not surprising that a lot of the drugs we talk, at least in our countries here in Europe, that we use every day are based on etheric oils. And of course, you know this one, and this one everybody uses in tablets, and it's all over the world, more or less, for usually for banal infections. And this one you might know from cooking, at least in the Western world, use this laurel leaves for cooking, but they're also good for as anti-infectious drugs. And isocyanates, this development is rather new, and I'll show you an example later. So what I always say is very important if you want to reduce the use of antibiotics, the use of phytodrugs or phytomedicine. Look what they can do. We all learned that antibiotics or antiviral substances, they can act static or cidal, bacteriostatic, bactericidal, virostatic, virucidal. Either kill immediately or inhibit growth, which is also a very good goal. With plants, it's different. You might have this action, direct, I would say, antimicrobial attack, get slowing down growth or just killing. But you also have different approaches, as I mentioned, relief of symptoms by not attacking the infectious agent immediately is a feature that is almost unique to phytodrugs. You will never find this feature in an antibiotic substance. Then defense mechanism activating of certain lymphocytes, of killer cells, and all this very complicated matter can be achieved by certain phytodrugs, but never by an antibiotic. Antibiotics are either neutral to defense mechanisms or they disturb defense mechanisms, which is an undesirable effect. It is usually not mentioned that way, but to me it is. And then we have the problem of biofilms. You think this is a new problem. You think that biofilms as a problem in antibiotic therapy has come up maybe 10 or 15 years ago. And it came up with a lot of reports on technical devices, that catheters, that type of thing, that are implemented in persons and rest there for days or even longer, and then you just take them and like this that the planktonic or singular life of bacteria is the normal way, and biofilm is something artificial. It's not that way. It's completely all the way around. It is estimated that some 98% of all bacterial mass in the on the globe, on the Earth, is organized in biofilms. It's the natural habitat, you might say, of bacteria. It's not. I show you pictures. The planktonic version, that's more or less the exception. So it's very important to think of these things. So in my outline, we're now back to preclinical assets. You had some wonderful examples in the talk of my predecessor. This was excellent work. I'll show you some more. Of course, we all have been very much interested in SARS-CoV-2 activities of natural compounds. So I'll show you this examples. This is a very good paper. And here you see that 4 plant extracts are tested, and they some have very good performance, some have very poor performance. So the most important thing is up on the right here, we have guidelines to do these investigations. This is a field that is very advanced, I would say. In contrast, I'll show you later, to clinical research. This is very advanced, and we can rely on these data. So you might not be Topberries in Europe is very modern. It comes from North America. We were not accustomed to it until just recently, and it's one of the candidates for respiratory tract infections. And here on the left side, you have the same experiment as 2 slides before, and on the right-hand side, I add with the same setup by this European guidelines, the activity against common influenza virus. And here you see that these 4 plants act very differently. They're all doing very well against common influenza virus, completely different than compared to SARS-CoV-2. And you have to know all these things to make a good decision when using phytodrugs to fight infectious diseases. So, as an example of the isocyanates. This is wasabi, which is used in all, almost all, in some form in all Asian countries. And there is excellent basic work comparable to the one you saw in the last talk here against coli and staphylococcus. And this is a very nice, I think, plot to register this. You have different concentrations and you have a timeline. So you see that here is more or less uninhibited growth, and here is almost complete stop of growth, and here's partial growth. So you can, in the lab, you can, of course, do these wonderful experiments, and you see that wasabi extracts have very good antibacterial properties. So here an example about saponines that I mentioned, and this example is very interesting as it points to a rather modern aspect, and that is cooperation. Some even say synergism. I would say it's a cooperation between conventional antibiotics and a phytosubstance. And you can, in certain cases, you can use them at the same time and do enhancement. I'm not going to the details, but here you see that activity of vancomycin against certain strains of enterococci that are resistant. You can buy these, you can use them in the lab, you know, they're standardized. And here, if you add certain plant extracts, you can see that you can overcome this. And this is a very tricky. It has hardly been used in clinical practice, and we do not have any good clinical trials to justify this, but this will be very hopeful. Now here, I'm coming back to this growth of the plants, of the bacteria, sorry. In these wonderful pictures, you have planktonic planktonic forms of living of bacteria that can be, this is a single, it's a Diplococcus, and then you have more or less multiple agglomerations, but this is not a biofilm, you know, it's now film structure, it's just attachment of few single bacteria. So this is the way they live, and like when you find bacteria, for example, in urine tract infection, and you give them to the lab, they're all in this way, more or less. So you think, oh, this is a problem, but it's not. The biofilm that is on the mucous layers of the urinary tract, this you cannot detect because they're attached there. This is a typical form of biofilm, and important is the reddish things. It needs a matrix. It's not only an agglomeration of bacteria, it needs a matrix. And bacteria, they form the matrix themselves. So if you can inhibit them forming this matrix, building this house, you know, or producing this glue, more or less, then you find biofilms. Okay, something wrong? No. So I'm going through this a little bit. Here you have a couple of examples about how natural isocyanates act against biofilm production. Here you have this EPS, this polymer substance, and that has to be, this is the production in the lab, you know, when you have the bacteria in their solution. And here you see that some of the extracts that have isocyanates may inhibit this to a certain extent. If you think of killing bacteria, this inhibition by 50%, that's not very much. For production of biofilm, this is very important. And here you see with different concentrations, you can even go further down. Here you have, again, EPS, and here you have the bacterial proliferation as planktonic reduction of growth. So this is very important to have this in mind. And you see that isocyanate mixture can have very good effects on certain biofilms. So what interests me most is clinical trials, and here we have a problem because we don't have so many that make a good proof of antibacterial activities. I'll show you one. These are complicated patients with chronic obstructive pulmonary disease, COPD, and they have elevated use of antibiotics. They have maybe 3, 4, 5 terms of antibiotics per year. And in this polycenter randomized controlled trial, these COPD patients took a commercial phyto drug. They used it for half a year, which is pretty long for a phytotherapy clinical trial. Mostly they're much shorter, and the rest took placebo randomized, and they were observed by their pulmonary doctors that they were accustomed to, and they could prescribe antibiotics to their free decision, of course. The drug is a complicated mixture, but it has been around the market. It's very popular in Germany, and it's distributed also in some other countries, and it's a mixture of different etheric oils that have been more or less been used in traditional medicines in the Mediterranean or in Asian countries to fight RTIs. So here is the number of exacerbations. Left green is verum, right is placebo, and you see 30% had an exacerbation, and about 60% had this with placebo, so about twice as much within 6 months. And here you see the number of patients that experienced them, and you see that it takes some time. It takes here about 2 months to have a real profit from this. You cannot expect this to happen from the very first day. It takes a couple of days. And what is very important, they're doctors, they're pulmonary specialists that usually describe antibiotics quite easily and that were blinded to the treatment. Here's their the outcome of their prescriptions within this half a year, and you see that placebo group received about twice as many patients that had prescriptions, and of course, depending on the relief of symptoms, the doctor decides on how many days this antibiotic has to be used. And here you see you have about half of the number of patients that were prescribed, and those that were described took half the number of days. So altogether, you have 1/4 of the overall consumption of antibiotics in this group that took the phyto drug as compared to placebo. That's a very nice, very good, and very important result. But unfortunately, it was only chosen as a secondary endpoint. And I assume that most of you are basic researchers, not clinicians. And in the philosophy and methodology and interpretation of clinical trials, it is very important to differentiate between primary and secondary endpoint. It's often, that's a little bit confused often. It would be very nice to have this as a primary endpoint, but the trial was not designed that way. Of course, seeing these data, it would be easy to design a trial with a primary endpoint, antibiotic consumption, that would prove this, but that never happened, unfortunately, so far. So here's one of our trials with a drug that has also been on the market in Germany for 50 years. It's a combination drug of 2 plants that have isocyanates. One, horseradish, is a little bit similar maybe to wasabi. It's a similar family of these strong, strong taste that you use for fish, maybe. And here, Propioli majoris is a wonderful flower from Latin America. So we use this for urinary tract infections, and we randomized the phytodrug against a conventional antibiotic. So then we counted responders. We took their bacteria count on day 4 of treatment, and those that had less than, day 7, sorry, that had less than 10 to the third were responders. And you see that in both groups, it's close to 50%. Now, why so little? First, it's only day 7. And on the other hand, we took an antibiotic, cotrimoxazole, that was recommended in the guidelines in these days, which is not anymore because it has problems with resistances. So that is why response is so little. And here is what we call a Kaplan-Meier diagram, the way, step by step, how both therapies act. And you see there's a delay in the phytodrug. It takes longer to get to the complete response, and the median delay is about 1.3 days. But finally, all patients are absent of symptoms, and there was very, very little use in the phyto group to additionally take an antibiotic. So, as a summary, this phytodrug proved efficacious in uncomplicated urinary tract infections of the urine bladder, not of the not renal infections. So the delay was about 1.3 days. If you can explain this to a patient, take this or take this, I can prescribe antibiotic or the phytodrug. With the phytodrug, you will probably take 1.3 days more until you get complete rid of symptoms, or then the patient can choose. That's very comfortable if you have these data. So here's some preventive. I'll tell you 2 preventive studies. In Japan, there's a lot of experience with antiviral, especially against anti-influenza drugs and strategies to fight this. There's a lot of problem, especially with the old people there. So here's a look at the description. A very high quality extract of Japanese green tea, and health workers were asked to take this for I think 12 weeks or placebo randomized, and here you see the incidence of they checked them whenever they had symptoms. They were health workers. They showed up, and it was very exactly registered whether they had flu or not. So we can actually, from this cumulative incident rate here, we can assume that this is all actual flu. And you see that under placebo, the incidence of flu rises much faster than the green tea extract. And again, we have a delay here of about 50 days, which is quite long. But if you take the season, maybe the winter season, as a risky season for flu, then, and you start this earlier, then you can say, if I assume that my risk is highest starting November through March, then I would start maybe in September to take this drug, or a lot of green tea, whatever. It's an interesting, very interesting trial. Now, this is last trial is on echinacea, which everybody knows. It's very common in Europe and Northern America. I don't know about Asian countries to treat especially respiratory tract infections. And here's a very nice and very recent trial from Switzerland with children that were randomized to either take a standardized high quality echinacea product, or 3 times 50 milligrams of vitamin C, which is not a real placebo. You might consider this as an active substance. That's up to you. And the primary outcome, they took this in a preventive measure for 12 weeks during the infectious season, November, December, January. And the primary outcome was sick days, which is a good outcome for children. They were 3 to 12 years old. And here you see you have considerably less sick days for the echinacea. And again, as a secondary outcome, antibiotics were measured. And here you see that the rate of children decreased considerably. And similarly, the days with antibiotics. And it is very similar to the first trial I showed you with the COPD patients. And it's about 1/4 of the overall load, I would say, for the whole collective of the use of antibiotics. So this is also a very nice and, of course, significant result, but still secondary, as I explained. We have to do trials where this is a primary outcome. And with children, it's very with complications, of course, everybody's afraid. The doctor and the parents are afraid of complications, otitis and tonsillitis and sinusitis and all this, So here you have in the Verum group, you have almost exactly half the frequency of children that were affected, and some had more than one compilation, surprisingly. So if you count the complications, you had about 1/3, and that's quite considerable. And but with less antibiotics, that's exactly what we want to achieve. But all secondary outcomes. So future trials have to be done that show that this can also be a primary outcome. So I'm coming to the final conclusions. We have sufficient data about in vitro antimicrobial properties of extracts of certain phytochemicals. We have sufficient data. There will be many, many more data in the future, I'm sure. For the reasons of time, I have not touched these 3 very important antimicrobial properties. So I would say, from my point as a clinician, we have almost abundant knowledge, which is comfortable on the preclinical effects. And there's a sharp contrast to clinical proofs of the efficacy and efficaciousness of these wonderful substances to do what we expect, relieve a patient from his symptoms, prevent complications, and reduce the use of antibiotics and to an amount that is really considerable. And in these 2 trials, I told you, 1/4 is a perfect result. We should not have the illusion that once we use only phytodrugs in infections situations, we don't have to use antibiotics anymore. No, the first step is use considerably less than 50% in ordinary like respiratory tract infections, uncomplicated urinary tract infections, skin infections, all these things that make about 90% of the reasons of the clinical situations why we use antibiotics overall. So a lot to do, and I think, as we say in soccer, the ball is on the clinical player at the moment, not the preclinical. Your preclinical people, you are doing a wonderful job, and we have wonderful basis on which we can work. But the clinical work is very important. It's expensive, you have to find patients, and you have to do a lot of bureaucracy and all this. We've gone through this many times, it's a real hard way compared to creating preclinical evidence, but it has to be done. So thank you for your attendance. I'm a little bit over time. You have